Alright, so here we are, and our lesson opener. Now that you've learned how to graph the simple ones, what we would like to do is to sketch the vertical and horizontal asymptotes and give their equations. So if we're doing that, I don't know if you can see mine very well for this first one, but you know that your graph should approach it. So we're not really even bothered with this equation right now. We're just going to draw them in there. So because mine's not very dark, that's one asymptote because you can tell this is approaching that line. This graph is also approaching a line. Looks like it's approaching here, but it's not really going past it, and neither is this one in the bottom. And then there looks to be a horizontal asymptote right here based upon how the graph is behaving towards infinity. So the equations of those, the first one is x equals -1. That's this one right here because it's a vertical line. X equals 1. And then y, this is your horizontal one, is equal to 1 as well. Okay, same thing for this one. You can cover my answer just a little bit, but not really. In case you can't see it as you're checking your answer, here is one of the horizontal asymptotes. Just kidding, vertical. Here's your other vertical one at x equals -2 and x equals 1. And then, if you can see this one as well, is at y equals 0. So today, similar to what we've done before, to find the vertical asymptotes, you're going to set the denominator equal to 0 and then solve. So x squared minus 1 equals 0, x squared equals 1, square root, x equals positive and -1. Always to find those two asymptotes. For this one, this is x squared plus 4x minus 2. You can set this equal to 0 and solve, and you'll find that x is equal to 1 and -2. Today, you won't be given a graph. We're going to be creating them, but those are some things that are going to help us to create them. More on that in a bit. 8.3, generally here, where you have these boxes, this should just be dot, 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 and dot, dot, dot. The thing about these equations is they're basically two different polynomials, one on top of the other, and then based on that, we're going to make some assumptions. So, for one, to find the x-intercept, we set p of x equal to 0. So p of x is always the numerator. So if you want to write yourself a note, you can put numerator equals 0. To find the vertical asymptote, always, always, always set q of x equal to 0. That's what we just did over here, and more so over here. So the denominator equal to 0. Now, this is where things get exciting. I'm going to go with that. So it's not always going to be a horizontal asymptote, but it'll be nice when it is. Here's when it will be. So there's two types of horizontal asymptotes that we're going to love. One is when m is less than n, and now you're wondering what the heck is m and what the heck is n. Well, where did those come from? Those came from these two, the degrees of the polynomials. If m is less than n, then automatically my horizontal asymptote is going to be y equals 0. For sure, for sure, for sure. So, have we seen that? Yeah, kind of, right here. So for this one, m, so it didn't have a variable here. I'm going to write that. It's x to the 0 power, because it didn't have one. X to 0 is 1. And in the denominator, it's x equals 2. So if this is the m and this is the n, m, 0 is less than 2. M less than n. So what's my equation? Y equals 0, which is what we see here. If you're looking at example number 1, that's the next example that we have over here when m equals n, because we have 2 and 2. If m equals n, then y is equal to, based on this, it's these coefficients, the leading coefficients. So this would be 1 over 1, which is just 1. I'm going to tell you, that's the rule for it, but typically, if I want to find the intercept, here's what I'm doing. I'm just going to say y is equal to the first terms, the leading coefficients, actually the first terms altogether, x squared over x squared. Well, what's x squared divided by x squared? 1. That's how we'll always find it. Basically, we'll just be using the leading coefficient, because if we do that, then that's going to make this, which is normally a struggle for people, a lot easier, because you're looking at all these variables and you're like, what the heck? We'll talk more about that in a bit. But for now, I'm going to talk about these. Basically what I just told you about is the step-by-step portion of this. Realizing that I skipped this key concept because I don't think it's as helpful for us. That's what we're going to do. So these are the steps. X-intercept happen when the P of X equals 0. That's your numerator. And then vertical asymptote, Q of X equal to 0. That's your denominator. Horizontal asymptote, we're going to use the chart that we just talked about. And then another thing, we're going to find the y-intercept by plugging X equal to 0. That's a lot of information that we're going to get from there. But after that, we're going to pick points between and beyond those asymptotes to end up filling up our chart and guiding us for how to graph these. So if you're ready, I'm ready. On the back of that page, we have our first graph. If you could do me a favor, that would be cool. If you could, what was I going to say? Oh, grab a highlighter if you have it, or a colored pencil. Be kind of helpful. All right, so step 1 is to find the x-intercept. So they tell me the x-intercept happens by setting the p equal to 0, p of x, which is the numerator, so x equals 0. That's wonderful that it's already done for us. As a coordinate, that's going to be 0, 0, because the x part is 0, the y is 0. The next thing, step 2, the vertical asymptote, q of x equals 0. So that's the denominator, x squared plus 1 equals 0. Solving it, x squared equals negative 1. What? Square root, we get I. Positive negative I. So that means there's not one. We can only graph, at least for now in this class, we're only going to be able to graph the real numbers. So for that, we're going to say none. The next thing, step 2, horizontal asymptote. Now we kind of use that chart, but I'm looking at this, the first terms. Y equals x divided by x squared. Oh, how many times does x squared fit into x? 0 at the end of the day, because this is too big. If you're looking at our handy dandy chart with the variables, this is 1 and this is 2. So m, the exponent m, is less than 2. So it should automatically be y equals 0. I just find that this m and n thing, oh, m is 1, is more confusing than not. So if I just set this up as a division, I know x squared does not fit in there. It fits in there 0 times. It's like asking how many times does 5 fit into 1. It doesn't. It's 0 times some decimal points, but we only want the whole number. So y equals 0. What's next? The y-intercept. And we know that the y-intercept happens when x equals 0. So I'm going to plug in 0 over 0 squared plus 1. 0 over, well, 0 squared is 0, plus 1 is 1. So this would be 0. So the x-intercept, the x part is 0, the y part is 0 as well. We kind of knew that though because this was 0, 0. So let's now, before we get to step 5, graph what we know. So the x-intercept was 0, 0. We know that. The vertical asymptotes, the line that would go vertically here, we don't have one, so that's none. Horizontal asymptote, though, is y equals 0. And now you might be freaking out or thinking, oh, we messed up. We didn't. It's okay, at least for like the middle portion of your graph, for it to go through the asymptote. But somewhere out towards infinity, out here or out here, it's going to approach it. Our job is to find out where that is. So I know where 0 is, and now we're just going to make a plain old basic XY table. And I'm going to pick some numbers to the left and some numbers to the right. So numbers I would pick is negative 3, negative 2, negative 1. I know 0 already, so I'm going to go 1, 2, and 3. A minimum of 6 points. It says 6 to 10 points on your directions right here. Do as many as you need. It's really not that deep. So what do I want to do now? Plug these in. So I'm probably only going to show you one because I believe you can do these. So y, let's go with negative 3. So negative 3 over negative 3 squared plus 1. Negative 3 over negative 3 squared is 9 plus 1 is 10. Negative 3. So this is negative 0.3. Now if you can please trust my math, then you will find the following. So this is what I get when you plug in these numbers into this equation. Don't believe me? You can please go ahead, press pause and check them all for yourselves, but this is really what happens. So my scale right now is by ones. That's not very convenient because I go from 0.3 to 0.4. So instead of going by ones and having to squeeze everything, I'm going to make each unit be 0.1. So this is now, instead of 1, it's 0.1. So when I go negative 1, 2, 3, I'm going down negative 0.1, 0.2, 0.3. And then for your next one is negative 2, negative 0.1, 2, 3, 4. And your next one is 5, 1, 2, 3, 4, 0.5. And then on the opposite way, you're still going by the same scale. 1, 2, 3, 4, 5. And then it was 4, and then 3. And you're like, what? This is kind of the coolest graph you'll ever graph in your whole entire life. But I'm going to press pause. No, I'm not. I'm going to do it live. So I know that this should approach. And so this is it approaching your asymptote. And then it looks like it does a little bit of a turn here. And then it starts going down. Then it changes directions one more time. And then from here, I'm going to approach the asymptote, but I'm not going to cross it again. I think that looks pretty. Next, they asked me to find the domain. Domain is your x values. From left to right, I don't see any holes in this graph. There's no gaps. There's nothing where it just doesn't exist. So I'm going to go ahead and say all real numbers. All right, go ahead, press pause, double check my work with your work, and then we will continue with the next graph. This video is going to cut off in like 3 minutes, so I'm going to go ahead and not do this graph now and tell you go ahead and start it, and then we'll continue it on the next video.